So today we're going to start our notes on FOIL, and this is just multiplying binomials. So we're going to make quadratics here. So FOIL, I keep saying that word, like, what are you talking about, FOIL? Well, FOIL is an acronym. It simply stands for first, outer, inner, last. Easy way to remember things. So you are going to multiply each piece together using FOIL as a guide and then combine like terms. So again, first, outer, inner, last. That's how we're multiplying.
Yep. Does everybody know how to do the FOIL method? Because I don't see nobody taking notes. Nothing. I know you will have a quiz and test on this in your future. I'm just saying that would be smart to write something down.
Yeah, we got 3 examples here. Thank you for that, Mr. Vaughn. Yeah, you definitely want to be writing this down. I know we'll post the notes, but again, this is going to be helpful. Just get used to writing it down. I know these notes aren't like our circle notes. I know our circle notes were a little bit of a pain, like, oh, I had to copy the pictures, all that. Like, I get the, not taking as intense notes during those ones, but this, it's not going to be too bad. So first, outer, inner, last. So what we're going to see is something like x plus a number and like x plus another number. So when I say first, that becomes the first term in each one. When I say outer, I'm talking about the outer edges. When I talk about inner, that's the inner 2 pieces. And when I talk about last, purple, there we go. That's the last number in each parenthesis. So again, kind of see this color, these colors lining up for first, outer, inner, and last. Again, do see some pencils writing for those that are watching this video later. We will be getting to the examples in just a moment. So there are a few other names this has gone by or goes by. Some people call this double distribution because basically, distribute the first term here, then distribute the second term. I like going with FOIL just because, again, it tells me what to do. Double distribution does kind of tell you what to do as well, but it's not as nice as, giving you a reminder of each step along the way. You guys have done distribution. We did that in previous classes. We got some refreshers on that at the beginning of this school year. So it's not like this is going to be anything super new or foreign. It's just expansion on the idea of distribution. Fun, fun, fun.
This grows right
Always got you busy, don't they? Yeah. I think we're ready to look at this in motion. So the first example here just says x plus 3 times x minus 5. So all I'm going to do is again follow FOIL here. Now I'm going to write it out like really like write out every little piece here. Some of you may say, well, writing the FOIL every single time seems to be a little much. If you're fine with just like kind of using the arrows and then combining like terms, it's absolutely fine. So I'm going to start with my first. So first is x times x. What does x times x give me? Not just x, but x squared. X times x gets us to x squared. So that gives me x squared. My outer, x times -5, what would that be? Yeah, -5x. Now my inner, 3 times x indeed does give me 3x. I like to put a plus sign with that because I'm about to combine like terms. I want to remember it's positive. This work. I got. You know what? Take the pass. See if you can get like an extra mask from the office. So then here, my last, what's 3 times -5? -15. Now, where are my like terms here? 5x or -5x and 3x. So your inner and outer are going to be your like terms. So those will combine. So I just started off, it starts off x squared, -5 plus 3, -2x minus 15. And that's it. Now, I am going to say, this is just a structure of organization FOIL. Some of you may say, well, I don't need to write out the letters FO. I don't need to write out the words first, outer, inner, last, or even FI or FOIL. I get what you're doing with the double distribution. I think the arrows are enough for me. And that's cool. If that's the case, that's cool. You know, you could just do it like, oh, x times x, that was x squared. Oh, it was a -5x. Then it's a plus 3x. And you can say, okay, my last is -15. And you can say, oh, right here, these were my like terms, and I combine them to get to that. I don't care how you write it out. I know some students, as we're starting to do it, feel more comfortable writing it this way as compared to this way, because this gives you more structure to help you with your thinking and logic here. And that's not a big deal. Some of you may say, as you're getting used to it, oh, this seems to be a little bit of extra writing that I really don't need to do, and get rid of that support. So again, just trying to give you the opportunity to get it as easy as we can. So the next example, exact same idea. The numbers get a little bigger because I have 2x plus 4 times 3x minus 5. So now you go write out the full word, so just go use F for first. So what's 2x times 3x give us? 6x squared. So remember, a lot of times this first is going to end up having the x squared, because whenever you do x times x, that gets you x squared. Now I'm going to do my outer. What does that give me? (2x times -5 would be -10x. I forgot to show how we can check on decimals. I'll do that in this example. 4 times 3x, what does that give me? So my inner is 12x. So I'm going to put that as a plus 12x. And then last, what will that give me? -4 times -5 is indeed -20. Again, combine those like terms. Thank you, Saban. So that gives me 6x squared plus, as you said, 2x minus 20. And that's it. So how do I know this is right? I know some people are still copying this out, so I will give you a second to get that down. Yep. Oh, but we're going to check with decimals to see if it's right. So when I multiply something, it shouldn't change what it fundamentally is. So what I'm going to do is I'm going to first graph this equation here, how it was originally written. Then I will graph my answer. And if those graphs overlap or coincide, then I know I did it right. If they do not match up, then I might go, hey, let's go back and check our work. So let's go ahead and take a look at that on Desmos right now. I'm talking about checking our work. So initially it said 2x plus 4 times 2, or no, 3x minus 5. And this is the graph it gives us, okay? So I said my answer was 6x squared. Clearly, if I had just stopped there, that doesn't match up. Then we had said plus 2x. Again, not really matching up, but that do minus 20. And all of a sudden, the blue and the red graph, these match up, right? So since they match up, I know that's my answer. If I had accidentally put this as a -2, notice how these graphs don't quite line up? That tells me I did something wrong. That's essentially what's going to happen on your warm-up, or not your warm-up, your do now starting tomorrow with Desmos. You're going to type in your answer, and you should see the graphs fall on top of each other. If they don't, go, well, okay, let me check my math again and try and get them to line up on top of each other. Any questions so far on this? Pretty easy. We got one more example here. This one, it's a unique example just because something happens to our like terms here, and we'll see it in a second. So let's go ahead and give this a try. So what do I get when I multiply my firsts together? 4x squared, perfect. What about my outers? -14x is correct, good. My inners, a +14x, good. And then my last, -49. Now I just have to combine my like terms. Well, what's a -14 plus 14 gonna give me? 0. So they totally cancel out, leaving me with just 4x squared minus 49. So this is what we call a difference of squares. This isn't just a pattern that comes up. Because it's a special pattern, it kind of worked out like kind of unique there with stuff canceling. That's why we give it a special name, difference of squares. You do not have to remember that pattern that, oh, if it's like the same thing, just a plus and a minus, it just ends up being the first term squared and the last term squared. You don't have to remember that because FOIL gets us there in what? This took maybe 30 seconds to do. So again, I'm not going to stress, oh, you have to memorize this pattern. You have to recognize it right away because the math's not that hard for doing it without memorizing something. So that is our notes for today. So make sure you are getting started on the classwork. Stop recording.